Okay, so we brought in some local experts on nutrients in the Tampa Bay area. So I asked each of them to introduce themselves and to speak briefly about some of the opportunities and barriers to implementing innovative nutrient technologies in the Tampa Bay area. So we'll start with Holly Green.
My name is Holly Greening. I am the Executive Director of the Tampa Bay Estuary Program. And one of the things that the Estuary Program has been involved with is helping to facilitate a public-private partnership for maintaining our nitrogen loads to Tampa Bay at levels that were observed in 2003. That level is now our total maximum daily load for Tampa Bay. And working with more than 45 public and private partners and participants in the Nitrogen Management Consortium, there has been agreement to cap our nutrient loads, our nitrogen loads at levels in 2003. Those are now being incorporated into permits, both wastewater and NPDES stormwater permits. And again, those have been voluntarily developed, but now are meeting regulatory requirements too. One of the implications for that is that when you cap nitrogen loads at whatever level, in this case it was observed in 2003, there is no more capacity. And so as we continue to grow in the Tampa Bay area, which we certainly are, the opportunities for a new nutrient removal technology, I think, are much more than opportunities. They're going to be a necessity. And so I think we need to be looking at all the different tools that we have at our disposal here. And so that, to me, is especially important here in Tampa Bay, where we've seen a remarkable recovery of the Bay over the years because of the reductions in nitrogen. But maintaining that in the face of growth is going to take new technologies and continued collaboration.
Okay. We've got Nan Bennett from the City of Clearwater.
Hi, I'm Nan Bennett from the City of Clearwater. I'm the Assistant Director of Public Utilities. We operate a water, a wastewater, and a reclaimed water utility. And in doing so, we have different nutrient challenges. One thing that's a little bit different here in Tampa Bay is that we actually have been dealing with nutrients for all of my career, for about 25 years, since I graduated here at USF. With Grizzle Fig, and about that same time as I was coming out of school, most all of the wastewater treatment facilities were being upgraded to advanced wastewater treatment. And we have been maintaining nutrient levels of 3 milligrams per liter or less with total nitrogen and 1 milligram per liter of or less of total phosphorus, which is very good nutrient management for wastewater industries. Additionally, like Holly said, we've also had TMDLs imposed upon us that we're having to meet those loads as well. But because of capping it at a certain time, we've had to look at ways that we could find other ways for the growth. We have to find other ways to cut the nutrients for the growth that happens in the future. And so Clearwater, like many communities around here, has done a variety of techniques and strategies to try to achieve that. One is reclaimed water. We have public access reclaimed water throughout our city, and that utilizes somewhere between 40 and 50% of our reclaimed water, and that takes that out of that's one mechanism for nutrient management, because obviously those nutrients on vegetation are a good thing. Putting them into an aquatic situation is not a good thing. That is very weather and demand variable. Even in the last 2 years, it's varied from 38% to 46%, depending on the weather here locally, and we don't have a lot of control over what our customers use in reclaimed water. So we've had to look for other ways. On biosolids, we do land apply those to get a beneficial use out of those nutrients. One of the ways we're looking for growth is there are a few remaining septic areas within our service area, and we're looking at taking those to a sanitary sewer so that we can treat that to a lower level and gain a little bit more capacity in that way. We are also doing a pilot project right now on groundwater replenishment. We looked at our long-term projections and realized that we probably weren't going to have beneficial use for 100% of our reclaimed, and yet we had a goal in our integrated water management plan to go to zero discharge if possible. So we're looking at purifying the remaining reclaimed water that comes off of our treatment plants to a very high level, near distilled quality, and then looking at a way that we can re-inject that into the aquifer and augment our drinking water supplies. That's what we're doing within public utilities. Additionally, at the City of Clearwater, we obviously are doing a lot on the stormwater side, and including participating in the Pinellas County Fertilizer Ordinance, and I can speak about those as well.
Thank you. I'm Dave Hagan. I'm with the firm of Greeley & Hansen. We're consulting engineers dealing largely with municipal clients. I've been with the firm over 35 years. First 10 years in Chicago, where they don't know anything about nutrient removal, and then coming down here 25 years ago, as Nan said, it's become old news to have what we call advanced wastewater treatment. But now here today, Mark is talking about something that's even more advanced than what we've had in the past, at least certainly more energy efficient. And I think what took place in the 1970s was that there was a requirement, a driver, to go to advanced wastewater treatment and to lower the nutrient concentrations from wastewater plants. And as Holly mentioned, it's been very beneficial to the bay. So to get to the next step, maybe energy efficiency, is going to take some sort of driver that may not be in place yet. But right now, many of the municipalities we deal with are very comfortable with the process that they have. They've been meeting their stringent permits for 25, 35 years, and there's a big reluctance to change to something else, a new technology. But as some of the equipment from 30 and 40 years ago starts to break down, I think there'll be opportunities to get that first plant in place. And Nan said that she might want to do some Animox treatment, so maybe she'll be the first one.
Okay, we'll take some questions from the audience now for the panel.
Hi, Colleen Naughton, USF. So my question was earlier for the lecturer, but I was wondering with Animox, for the granular Animox, what the cost of that was, and does it easily, do you easily make that up in the energy savings, and do you have to keep replacing those granular Animox and ordering it, or does it sort of like multiply within the system?
The granules just multiply in the system, so small pieces break off and grow out to granules like flocks, so you have to harvest sludge now and then. So that's unstable. Very similar to USB reactors. The energy issue is very much depending on local energy cost, of course, because the price of electricity is very variable. I think in the Netherlands we would pay, I've replaced to dollar cents, $20 or something per kilowatt hour. I don't know what the price is here. And but I don't think if you count it really on energy that it will be profitable. Also not in the Dutch electricity prices, but if you count methanol, which you otherwise would use, it is. So the methanol costs are way higher than the electricity cost. And partly also, if you then also account the sludge you produce on methanol as a cost factor, which is not always done, but that is a cost factor, then it really becomes, so in the Netherlands, this 3 years was calculated only on methanol cost. If you include the sludge, probably it's 1 year or something payback time. Hi,
I'm Matt Verbila from USF Environmental Engineering. My question is related to the use of molecular techniques. I thought it was really interesting in the talk hearing how this feasibility of Animox at the full scale may have never been discovered at that time if it wasn't for this data that was provided through molecular testing. So I guess for the other panelists, have any of you had experience with using molecular techniques to find more about how your systems are operating or how to optimize nutrient management in your systems, and if you could share those experiences?
Be a good. It's a good question. I'm going to go off script, sorry, but ask a little bit about operator training. And I know you talked, Mark, about going full scale first, and so that must have been very concerning for the operations staff at the facility. And maybe you could talk a little bit about the background and training for the operators, and maybe, Nan, you could talk a little bit about the way, when you have new processes. I know you're right in the middle of this big pilot, how that you get buy-in and the training of your operations staff.
Yeah. I think there are 2 points to that. One aspect is, at least what we try to do is, if you think about, we have some new idea about a process, we start to think, what can an operator do wrong? And try to prevent in the design that if the operator does something wrong, that it will influence the process. Like with, if you treat sludge digester effluent, you know that the operators will not operate their centrifuges as you do that in the lab. So there will be sludge in it. So if you design a process which gets troubles as that sludge entering, you know it's unstable, you get problems with the operators, and you have to train them and you have to explain them. So if you upfront think about how you design the reactor and the process, you already save a lot in operator training and a lot of annoyance, because the operators don't like to do things just because your process needs that. It's only if that's if you have to do that. The other thing is, like we do now with the side stream treatment is not such an issue, but like for the aerobic granular sludge near Reda, but now again for this Animox plant, it's a 4 cubic meter pilot plant at the wastewater company who's potentially going to use it, and the operation is done by the current operators. It's not done by the PhD students. And that makes a big difference, because of course these operators do it less efficient as when a PhD student would do, so it would go initially way more quick with PhD students, but doing that pilot plant together with the operators, you figure out where they go wrong or what is happening, so you can adopt the process, and they learn already the process doing the pilot plant. They are involved in what is happening at that pilot plant, what's going to happen at that pilot plant, and it means also once you construct the large-scale system, it's a little bit also their baby, and they take care of it, that it will run well. And at least that's my experience with introducing technology in practice. That's how I would look to it.
As Dr. Yergas said, we have a pilot plant of a groundwater replenishment system that we're doing at our Northeast wastewater treatment plant. And what we did was we partnered with our operators. We asked for volunteers, we explained what we were trying to accomplish, and we are utilizing only those people who are invested in this, because an operator can make or break any operation. And it does put them in a huge, in a very difficult position where you have to give them permission to fail and explain to them that if they fail that there will be no negative repercussions, because we're learning, and so there may be some failures. And the other thing we do is literally go out there 1 day a week. We have some of the engineering staff go out there and work side by side with them. Although they carry the bulk of the operations loads, 1 day a week they've got that resource there. And when we do meetings and tours and promotions, we try to include them and make sure we acknowledge their part in it, because it's essential.
More questions from the audience?
So this is kind of a holdover from the lecture earlier, but When you were developing or trying to develop the biofilm on top of the granular, was that something that you had kind of planned on and intentionally done, or was it just kind of a happy surprise?
No, that we planned. That's, no, it's simple because if you in a normal Anamox reactor you won't aerate, so you don't get. So you have to aerate. So you plan that you get the nitrifiers on top of the granules.
So I think thus far we've talked mostly about wastewater plants, and Holly, I'm interested in getting your take on. There's significant nitrogen loading into Tampa Bay from stormwater and atmospheric deposition. So I think on one hand we can keep asking wastewater plants to apply new technologies and go down to lower limits, but what about stormwater and atmospheric deposition, and what can we do about that?
Stormwater now is our largest source of nitrogen to Tampa Bay. Before, the wastewater treatment plants employed best management practices and AWT standards, advanced treatment standards. The wastewater treatment plants contributed about 60% of the total nitrogen to Tampa Bay. Now most of our nitrogen loading is coming from stormwater and from atmospheric deposition. I think, that's actually, I had a question for our speaker having to do with that. I was really interested when you said that 50% of denitrification in nature is done by organisms, and as a biologist, I really like that a lot. But I'm wondering if you see a way to enhance some of the types of Anamox types of systems in nature, or perhaps in stormwater ponds that might be outside of the wastewater treatment plant realm and more open air. And I'm wondering if you see a mechanism there or a role there.
Yeah, so that's also, from my point of view, one of the things that until now we have actually engineered systems which are wastewater treatment plants, and for a part we're reaching demands, at least from the water quality people, on nitrogen concentrations in the surface waters and other things which are so low that you get atmospheric deposition, other sources which are hardly to control, and that would call to better understand, for instance, the nitrogen cycle in Tampa Bay, and see if you can take action to increase, if you think there's too much nitrogen, to increase denitrification either by Anamox or conventional. And for that you would have to study, of course, then what's going on. And the point is, of course, at least what I see in Europe, that if you start to propose that kind of actions, that goes a bit against the intuitive feeling that it should be nature. And if you start to engineer, somehow it doesn't feel good with public, and it might easily with environmentalists end up, well, you're already messing up a lot, and now you're going to take even more actions to mess up things. So it's in public perception, it is a sensitive issue, but I'm convinced that better understanding the cycles, and there's, as an engineer, well, I was trained as a microbiologist, by the way, but so I think I can say something about microbiologists. Microbiologists, they are very interested to see what is there, and not how rapid they are converting. So they see the organisms are there, like biologists does, but not rates, not fluxes. And if their engineers and biologists would work a bit closer together to understand the rates of processes, and then to influence that on the rates and not on concentrations, you might improve the overall quality of the water in a more natural way.
Hello, I'm Peter Roish from ICT Prague. Since I have this great opportunity to ask you in personal, what do you think about Anitamox process you have mentioned? Because I worked for Veolia a couple months, and there are many problems with that Anitamox process, especially with temperature fluctuations. So is there a future or for some way how to progress this process? Thank you.
It's difficult to comment on it. From my point of view, if you look to the design, you have to buy these rings and other things. It will always be more costly in investment than when you can apply granular sludge or even flocculant sludge, granular sludge with cyclones. But the market works, of course, a bit different because Anitamox is developed by Veolia, and Veolia is quite dominant in the market, so that process will be around. And I personally also have a bit negative feeling with it, but I'm hesitating to make too strong comments on the process which other people are developing. But the principle works, but I think the MBBR application is just more demanding. And the problem at the treatment plant is that this, certainly if you apply it as a side stream reactor is small compared to the mainstream reactor. The pumps are small, the volumes are small, so the operators intuitively will first pay their attention to the big pumps, the big mixers, and if they have time left over, look to this small tank which is somewhere in the corner of the installation. And that gives problems with maintenance, keep getting it. So you have to design it in a way that the operators only need 1 hour a week attention, and if they need more, I think it's the side stream process will fail.
I have a question for all four of you. I was wondering, what do you think is the most important aspect in managing nutrients in your field? Is there not enough technology, or would you rather think that public education would be more important in managing nutrients? What would be the most effective strategy in each of your cases?
Start with David.
Well, since we design wastewater plants, I guess we prefer the technology. But the technology is now pretty well advanced, and it's actually now creeping up into the Chicagos and other areas that are thinking about the same thing. It's pretty universal when you look at a wastewater treatment plant anywhere. The amount of nitrogen coming in is 35 to 40 milligrams per liter. So that's what you have to deal with almost every treatment plant. Now, in Europe, in the plants that Mark has been talking about, their expectations are to get the nitrogen down 75%, remove 75%. We're actually a little bit more restrictive in this area with a 3 milligram per liter discharge limit. And then also now with the maximum daily loads, I think ultimately we're going to be looking at ways not to get the nitrogen any lower, but to do it more energy efficiently, and then also to do more reclaimed water type projects where we remove the nitrogen from the discharge and put it off someplace else.
Well, you did a good job of answering the wastewater treatment plant question. So I'll answer it for the city on a overall nitrogen discharge basis, our entire combined NPDES, and I would say that has more to do with our MS4, our stormwater side of that. And I would say yes, it is citizen involvement. It is awareness not to blow your clippings down the storm drains, and to do everything you can do only to fertilize, in the non-rainy seasons. And the things that Pinellas County and the city of Clearwater and Tampa Bay Estuary in combination, we are all part of the Nitrogen Management Consortium, and those are the types of efforts that we're making to bring the public on board with us and understand the importance of some of these things we're asking them to do, because there's only so much you can do as a government or an agency without their cooperation.
Yeah, so I think partly technology is there, and then for wastewater treatment you can optimize it a bit, But if you want to go further, as I said before, I think collaboration between biologists and engineers in understanding, also in an engineering-wise, the ecosystem and influencing nitrogen sinks or phosphate sinks in the ecosystem so that you can bring the levels there where from a biological perspective they are proper, might be a much better development than trying to get another milligram lower in the effluent of a treatment plant. So there I see a need to much better interaction between biologists and engineers. And on the resource recovery aspect, also there are certainly for phosphate technologies there, but for the overall resource recovery there, I see that what is lacking is a good logistic chain for bringing nutrients, for instance phosphate, back from treatment plants into the phosphate supply market. That link between, say, the waste water market or the waste market and the more resource market, the supply chains, is actually almost non-existent, and that needs development. On one hand, maybe legislation, but also how do you arrange it? How do you get price levels in the right way? How do you get product qualification in the right way? So it's a lot of product management. And for nitrogen, I'm still looking to a way to recover nitrogen in a way that it requires less energy than recycling through NMOX and the Haber-Bosch process. That's a very efficient route. That's the most efficient route for recovery at the moment. But it would be good to have an even more efficient route if that's possible.
I think given our pie of nitrogen loading, if you will, here in Tampa Bay, everyone is part of the problem and everybody's part of the solution. But one of the things I really see, especially in Florida and in other areas where we have a lot of new people coming in all the time, is the need for continuing not just education but sort of social marketing, where we're really looking at how can we encourage people to change their behavior, not to water their lawn as much or not to blow their clippings down into the gutters, and that is a continuing need because of our population changes very, very rapidly over time, and we get a lot of new people in here that have not seen how effective a community can be in terms of helping to meet long-term goals. So I think the education and social marketing has to be a critical piece of this, but I think equally important is technology and collaboration. So it's all piece of the pie.
Okay, with that, I didn't plant that last question, but thank you, Tom. It was perfect. So I'll invite everyone now to come to the reception.